This is section 3 of unit 10. We're talking about using chords and what we can do with them to help solve for different things. I have 4 theorems here that I do want to talk about. I already have those definitions written in, so if you want to pause and write them in as I explain them, or pause right now and go ahead and write those blanks in, go for it. But I'm going to go ahead and start with this first theorem. This is congruent corresponding chords theorem. It's stating that in the same circle or in congruent circles, notice it can be either again, so same or incongruent. 2 minor arcs are going to be congruent if and only if their corresponding chords are congruent. So it's the chords that are creating those 2 minor arcs. Notice how it only says minor arcs. I can only create minor arcs with my chords. I cannot create anything larger. The only other thing I can create with a chord is the semicircle, because a diameter is a very specific type of chord. Other than that, I cannot create straight lines that create larger arcs other than a single chord that creates both. So over here, I have perpendicular chord bisector. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. I went ahead and put the markings in the picture of what it does. So because EG is perpendicular to FD, I can go ahead and conclude that FH and HD are going to be congruent, as well as arc FG and GD are congruent. Over here is the converse of that. This is the way to prove if a specific chord is a diameter. If one chord of a circle is a perpendicular bisector of another chord, then the first chord is the diameter. Like I said, this is the way to determine if something is a diameter or not. And then my final theorem, which we will have to use here in a moment, is the equidistant chord theorem. In the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. That is very crucial to determine if some chords are congruent. Also, it helps us determine things like radius or diameter of measures. So let's go ahead and look at this first example, and it is missing a little bit here. We're going to say 7 right there to help us solve this. So we are trying to determine in this problem the measure of segment HK and then the measure of arc HK. So let's start with the measure of segment HK. So I know that MJ is perpendicular to HK. Since they are perpendicular, it creates a bisector, making HN and NK congruent, meaning they are both 7. When I add them together, I get 14. And since I don't have a unit of measurement, I don't have to put anything there. I can just leave it as 14. So the next part of this is my arc. So because it's a diameter, a perpendicular bisector of a chord, I also know that the arcs are congruent as well. Meaning to solve for x, all I have to say is 11x is equal to 70 plus x. When I subtract x from both sides, I get 10x to equal 70, and x will equal 7. Now once we find the measure of HK, so the measure of arc HK is going to equal all of that added together, so 11x plus 70 plus x. This gives me a total of 12x plus 70. Another way I could have done this is go ahead and plug that 7 into each individual arc and then add those together. That is also a good way to verify that yes, you did do it correctly. So either way, I can go ahead and plug 7 in here and say that 84 plus 70, and the measure of arc, HK, is going to end up equaling 154 degrees. Okay, so my last example here is going to be determining the radius, but we have some information that we are given. So I am told in this diagram that QR is equal to ST, making them congruent, and they both equal 16. So I'm going to say all of this is 16, all of this is 16. What that does is it tells me that CU is equal to CV. Change that color real quick. Bring that down here. And it's telling me I need to find a radius. Well, I have a couple different options that are in my picture already for a radius. I have C to W, and c to x. Now, the issue with using one of these two is I'm only given parts of them. So I'm only given c to u, so I cannot infer what this is going to be, or I don't have any other information that could tell me. Same thing here, I'm not given anything about this part, I'm just given this little bit there. So what I have to do is actually create a radius with some of the information, or that's connected to some of the information that I do have. This lovely bit of information is going to be this one right here. Oops. Here we go. Because now I have a lovely right triangle. And we can use the Pythagorean theorem to help solve for the radius. So this is going to be my radius here. So I'm going to have QU squared plus UC squared is going to equal QC squared. Well, I have CU is 2x, CV is 5x minus 9, and I've already done something with that over here. Right here. Change this back to blue. So I'm going to go ahead and figure out what UC will equal by solving for x first. So I have 2x is going to equal 5x minus 9. When I subtract 5x from both sides, I get negative 3x is equal to 9. Divide by negative 3, I get x equals, or sorry, negative 9 there. And I get x equals 3. This gives me 6 here. And if I plug it in there, I also get 6. So I do know that I did solve it correctly. So this will end up being 6 squared. Now I need to figure out what QU is, because I do know QC is going to be r squared. So I need to figure out QU. And what I know about QU is that it is part of an entire chord that is 16. That is something that we were given earlier, that the entire chord is 16. There we go. But what I don't, or what I can infer is that my diameter WX is perpendicular to QR. Since it's perpendicular to QR, it now becomes a perpendicular bisector of that chord. So I know that QU is going to be half of 16, which is 8. So this gives me 8 squared. So when I solve this out, I get 64 plus 36 is going to equal r squared, which is 100 equals r squared. And when I take the square root of both sides there, I get radius to equal 10. And since I don't have a unit of measurement, I don't have to do anything else. Also, we do need to kind of recognize the fact that the square root of 100 is actually plus or minus 10. But since I'm talking about the radius and nothing else is connected to that r to make it positive, I only need the positive version of that. But just keep in mind that sometimes you may have to use the negative value when doing a square root. This is the end of section 3.